We're recording.
Oh, so we're recording. See, we're a little rusty. Hope you had a great break. And here we go with our next lesson, complex numbers. And guess what? You did this in Algebra 2, but we're going to just uber do it a little bit more difficult. So now we come to a number called I. I is an imaginary number which is defined to be the square root of -1. Where you actually see this more often is that when we see a number -1, we want to think of it as I squared. Notice i's come in pairs, I squared. Okay, so now we can find square roots and of negative numbers. So let's first of all look at this square root of -25. Now what we want to do, the easiest way to think about this is write this as the square root of 25 times -1. Notice how the parentheses are important. Now what do we know about 25? 25 is 5 squared, so we're going to write this equals the square root of 5 squared. And from what we just saw above, -1 is the same as I squared. Oopsie, -1 is the same as I squared. And now when we take the square root, let's remember that the square root means the principal square root, which means the answer which is not negative. So the square root of 5 squared is 5, the square root of I squared is I, and there's our answer. Okay. Now, letter B here has a little bit more of a problem. It's got a negative on the outside. We'll address that negative on the outside in a little bit. So let's first of all do what we know how to do at the beginning. So it's a negative times the square root of, well, we know that 81 is 9 squared, so let's go ahead and write that as 9 squared. And we know that the negative is the same as I squared. So what do you see that we have here? Close parentheses. We have, there we go, negative times, now the square root of 9 squared is 9, the square root of I squared is I, and so we would write this as -9I. Boom. Okay. All right, moving on to letter C, square root of -7. This one's pretty simple. Let's write that as the square root of 7 times I squared. Now, the only thing which can come out from under that radical is the I squared, so we're going to write that as I on the outside times the square root of 7. And now, when we look at letter D here, what we see in letter D is that is not a perfect square, so this is one place where you need to remember old stuff, and that is how do we simplify a radical that's not a perfect square? Well, let's factor it. So first of all, that negative, let's write that as -1. Let's write that as a -1. In parentheses, times, what is the biggest perfect square in 44? Hopefully you saw the number 4, times 11. Now, what do we know about the square root of -1? By now you should know that that is going to be I squared. Well, we haven't done the square root yet. And we know that 4 can be written as 2 squared, and 11 cannot be written as a square, so it's just 11. And so outside we get I times the square root of 2, 2I, times 11. I did not mean the square root of 2. I meant 2I. Square root of 2 squared. There you go. Okay. Now we'll talk a little bit later about how to refine that, because actually when we go start writing in the A plus BI form, we kind of rearrange those a little bit differently, but we'll do that soon. Okay. All right, now we have properties of a complex number system. The complex number system contains all real numbers. The addition, subtraction, multiplication, and division obey the same rules that the rules of arithmetic took hold in the number system, but the exponent laws do not. They hold for integer exponents but not fractional exponents. Now that's kind of hard to explain, so we're going to show you what that means. If we looked at the square root of 6 times the square root of 24, because those are both square roots, we could write this as 6 to the 1/2 times 24 to the 1/2. Now what can we do with that? Well, from old material you know that with that exponent being the same, we can now write parentheses 6 times 24, all of that to the 1/2. And now we could do 6 times 24, which turns out to be parentheses 144. And hopefully you know by now the square root of 144 is 12. Well, when we have a negative under the radical, you cannot do that. Okay, so what we actually have to do is deal with that I first. So that -6 under the radical, you should immediately know that outside of the radical is going to be an I. And now you have square root of 6. And that negative 24 under is going to be an I outside, square root of 24. Now, let's look at what we have here. We have an I times an I on the outside, which is I squared. And under the radical, we have 6 times 24, which we know, of course, from the last problem, that I squared is, 6 times 24 from the last problem. We know that the square root of that's going to give us 12. And I squared is, negative 1. Notice once again our beautiful parentheses that we like to use. And so the answer here is negative 12. So what this last law means is that what we could do with exponents that were fractions is what was in the blue over here, but you cannot do that. You have to deal with the I first. Other rules are the complex number system contains a number denoted I such that I squared is negative 1. Every complex number should be written in the form a plus bi, and that's what I referred to a minute ago, is that we would adjust how we write our steps. And that two complex numbers are equal if, notice the a and the c. A is equal to c. Those are what we like to call the real part of a complex number. And the bi and di, those have the imaginary, so we like to call the b and the d our imaginary part. Okay, just something for you. All right.
So the real parts have to be equal and the imaginary parts have to be equal for both complex numbers to be equal.
Yeah. Okay, now we're going to just do some basic operations. Okay, some of you have trouble with noticing that you have pluses and minuses, and you would see problem A and problem B and look at those and immediately FOIL. Please notice these are not foiling problems. So in part A, we're just going to distribute a positive, so let's write it as 2 minus 3i plus 1 plus I. And we have common terms. What is common? The real part, so I can do 2 plus 1, which is 3. And then the other common thing is the imaginary part, so I have a negative 3i plus 1i, which is negative 2i. And note that the instructions say to write it in a plus bi. That means your real number plus your imaginary bi. And we have that here. Our a is 3 and our bi is minus 2i. All right, so letter B, we're going to distribute a negative. So all we're doing is just your basic operations of distributing negative, and here we go. 2 plus 3i, now that's going to be minus 4, plus 2i. Once again, we do the same thing we did last time, which is add the similar parts. 2 minus 4 is negative 2, and plus 3i and plus 2i is plus 5i. Boom, we're done. Pretty easy, wouldn't you say?
I would say.
Okay. Part C. If you look at part C, it looks like all you're being told to do is distribute. So let's do that. We're going to multiply each term inside the parentheses by 10i. So that's going to give us 50i there. And 10 times 1/5, please tell me you know that that would be 2. And the I times the I is I squared. Now you can see here we have more work we need to do. What do you see? Aha, we see I squared. So what we're going to do is write this as, once again, 50i. That's fine. 50i plus 2 times parentheses I squared is negative 1. And you can see that's going to give us 50i minus 2. Look up at the rules. It says to write it in a plus bi form. So we're going to rewrite that as negative 2 plus 50i. Simple enough, really. Now we finally get to FOIL. So what you know from the past with FOILing, we're going to do exactly that. And we're not going to do anything special. We're just going to FOIL. So first is going to give us 3 times 2, which is 6. Outer is 3 times negative 5i, which is negative 15i. Inner is plus 2i. And last is going to be minus 5i squared. Don't do anything tricky here. Next step, we will combine the two similar terms and deal with the I squared. So we have 6. Minus 15 plus 2 is minus 13i. Minus 5 times negative, let's go ahead and deal with that I squared. So at this point I would say, okay, we know that I squared is negative 1. So now our term becomes 6 minus 13i plus 5. And now we're going to simplify that and write it in the correct form all in one step. 11 minus 13i. Yay! Simple enough. And now our ET, or entrance ticket. We're going to do things a little differently, so throughout the lesson you will be asked to go to your textbook and work these problems. What we want you to do is do it on your own notebook paper. You will be turning these in, and please have them nice and orderly. So pause your video and go to the textbook and do these 4 problems.
These problems are the type of problems that we've just finished in the previous few slides.
Right. We thought it was easier. We thought it was easier for you to see instead of a bunch of problems at the end, it was easier to put them throughout the lesson. That helps you reinforce it immediately. Okay.
Next example. Here we go. Now we're going to perform the indicated operations and write the form in A plus BI like we did before. Now this looks, at first glance, it looks exactly like the FOIL problem that we did just a few minutes ago. However, if you recall old information that we did a lot of last semester, if you looked at this, this sure does look a lot like a special pattern problem.
DTS, DITS, it looks like a DITS.
Which would be?
Difference of 2
squares. Okay, so we've got a difference of 2 squares. What? Oh, yeah, factored form, difference of 2 squares.
Yeah.
I see what you're saying.
Yeah.
All right, so this is really...
Write this over here to the side.
Okay, so we have A plus B times A minus B.
Which gives us
A squared minus B squared.
So if we recognize that pattern, look how much easier. We don't need to actually spend the time foiling. We can go straight to the difference of 2 squares steps. So this would be 4 squared is 16 minus parentheses 5i quantity squared. Now you should be able to go straight to that, and that's 16 minus 25. Now the I squared, and now deal with the I squared, and that gives you 16, and you can see that that's a -1, which becomes plus 25, answer of 41. Isn't that neat? If you know the pattern, it saves you a whole lot of work. What about the next one? This is what I used to call a perfect square trinomial pattern, and that would be that A plus B, the quantity squared, gives us
square the first, square the last, double the middle, get out fast.
Yes, and that sign is always the sign
of the middle
term. Okay, so here we go. Let's follow that pattern. 3 squared plus 3 times 2, 2 times 3 times I. That's fine, you can do that. Or we could just go straight to 6i. I like that better.
2 times 3 is 6. Okay.
Plus, and let's just write I squared. At this point, every time you come to the I, actually deal with making the I squared. And then in the next step, go deal with the -1. All right, so what happens here? You know that 3 squared is 9, plus, nothing happens with the 6i, minus 1, or plus a negative, and this gives us the grand answer of 8 plus 6i.
Yay!
Pretty nifty. And now something really cool is the patterns that we have involving I. So if we take I to the first power, of course anything to the first power is itself. We know from this lesson I squared is -1. Now let's look at I to the third. I to the third can be broken down as I squared times I. Now what do you know about I squared? Well, I squared is -1 times the I gives you -I. I to the fourth can be thought of as an I squared times an I squared, which gives us -1 times -1, which is 1. And these patterns are super cool and very important to know. So let's think about I to the 40. The goal here is if we can take that exponent and write it as a multiple of 4, we can do something really neat with it. Now sometimes we have to pull out a multiple of 4, but in this one 40 is a multiple of 4. So let's write this as I to the 4 times 10. Now a way we could pull from old information to think about that is, why don't we write that as parentheses I to the 4th, all of that raised to the 10th power. Now why would we do that? Because I to the 4th is 1. So we are now looking at 1 to the 10th power, which is 1. But if we go to B, notice that 73 is not a multiple of 4. So I want to write this as I to some power that is a multiple of 4, and we want it to be the biggest number, which is smaller than 73. So it turns out to be 72. 72 is a multiple of 4. then plus 1. Now what in our exponent rules do we remember from that? That would be I to the 72 times I to the 1. Now, what do we know about I to the 72? If we're really technical, that is I to the 4th to some power. I don't know what, but whatever, we know that I to the 4th is 1 times I to the 1, and so we get just plain old I. That's why you want to actually deal with the exponent, one of the exponents being a multiple of 4, because anytime you have an exponent that's a multiple of 4, that's going to eventually break down to 1.
Okay.
Okay? And now we're ready for ET problem 2.
So go to section 4.5 and do these 4 problems, 12, 13, 18, and 20.
They're pretty quick.
All right. Now we're back. We're going to talk about conjugates of complex numbers. And you should know conjugates from our square root stuff from last semester. You know that a conjugate is a plus, it's the opposite sign with the same numbers, okay? So these are called conjugate pairs when you have a plus bi and a minus bi. So when you have a product of a conjugate pair, then you're going to get a real number when we're talking about imaginary numbers or imaginary complex conjugates. And so we end up getting something that sure does look like an interesting pattern that we never were able to factor before. It looks like the sum of 2 squares, which was illegal last semester.
In fact, a lot of you would take like a squared plus b squared and factor it as a plus b, the quantity squared. And of course, finally, at the end of the semester, I was telling my students, kill me now anytime you did that because it was a deathly sin. Well, now we can actually factor that.
We can factor it, but now we have complex factors. But it's factorable with complex numbers. So, since a and b are real numbers, a squared and b squared are non-negative, and this is what we get. To find a quotient of complex numbers, you need to multiply the fraction by the complex conjugate of the denominator. You cannot have an imaginary number in a denominator of a fraction.
Just like we used to not be able to have that square root. So like if it was 1 plus the square root of 3 on the bottom, we had to multiply by 1 minus square root of 3. We're going to do something similar here.
So here we go. We've got to simplify this. So we've got negative 2 plus 5i over 1 minus 2i.
Now, one of those we have to look at the conjugate of. Which one? It's the denominator. So we're going to multiply that denominator by its conjugate.
So that would be 1 plus 2i. Now remember, back in elementary school, or in Algebra 1, when you had to multiply a fraction by a number, you had to multiply the numerator and the denominator by the same thing, otherwise you change the fraction. So we're going to multiply the stuff on top by the same thing as we're multiplying the stuff on the bottom. All right, so this is now a foiling problem on top, and the sum of 2 squares on the bottom.
Yeah, it's actually foiling on bottom, but if you recognize, do you see the a minus bi times the a plus bi? So that gives us our difference of 2 squares. So you should be able, let's do the bottom first. You should be able to immediately go to squaring the 1, which is 1, plus squaring the 2, which is 4. It turns out that that minus 2i times the plus 2i is going to give you minus 4i squared, which eventually becomes 1 plus 4. But if you know the pattern, it is so much easier. Unfortunately, on top, there's no shortcut. You just have to stink and foil it out.
So negative 2 times 1 is negative 2. We've got negative 4i plus 5i plus 10i squared.
Again, don't deal with that i squared in this step because you'll make negative sign mistakes.
Yes.
What can we do now?
We're going to go ahead and get all of the common terms together.
And
I'm going to simplify the denominator.
And we can also, because we know now we're really smart, we know what I squared is, so we can do several things. So the denominator's the easy thing.
So we've got negative 2 minus 10.
Well, don't do that yet. Let's do the negative 2. Let's do the negative 2. Let's deal with that.
Plus I.
Now that's a minus 10. Now the next step, let's combine our real parts.
Over 5.
Is that the right form? Let's go back to the instructions. It says right here,
standard form.
a plus bi. It's not in a plus bi. So to write it in a plus bi, our a part is the part that has no imaginary, plus b is actually, the coefficient of that I is 1, so 1/5, and then the I comes after it. There's your a plus bi form.
There we go.
Yep, cool.
All right. Okay, now here's another ET problem, go ahead, go to section 4.5 and do number 27. Don't forget to show your work. All right, here we are again.
Okay, when multiplying and dividing radicals, blah, blah, blah. So we've been through this a little bit before with some other numbers, so let's try it again. What do we see, Miss Miller, that we can do here?
Here I've got a square root of -5. I know that the square root of a negative number is automatically going to have an I in it. So I'm going to go ahead and I've got the square root of I squared times 5, which is the same thing as I times the square root of 5.
Yep.
Times the square root of 10. Well, I know that the square root of 10 times the square root of 5.
Wait, I got an easier way to think about it. Okay.
5 and 5, and so that
do
becomes
square
5.
root, do square root,
5
and do
times
5 here, times and 5 times 2. Now we don't have to multiply and then divide out. You can see there's 2 5s, and automatically there you go.
Yep.
Now, could she have done square root of 50?
Square root of 25
yeah,
and 2? Yes.
See how it saved her a step? And we're going to try to utilize that idea and that thinking in the next problem. So the first thing we want to do, notice here, what you might want to do is, let's just multiply those together. But if you think back to a few examples ago, we've got to deal with the I first. So you can see right now that we have I times the square root of 8 times I times the square root of 6. Now, what do we have? Let's write all under one radical. The 8, what do we have in 8 that also is in 6? How about 2? So let's write 8 is 2 times 4, and 6 is 2 times 3. Now, what do you see that we can do?
Well, 2 times 2 is 4, so I really have 2 4s under here.
Yeah, you do. So let's kind of draw a little thingy here and say that that really is 4. So I'm really looking at 4 times 4 times 3, so outside is going to be a 4. Tell me about that I squared.
Well, that's really -1.
Okay.
And then I've got the square root of 3.
Yep. And so what do we really get in this problem?
-4 square roots of 3.
There you go. Notice the I totally went away in this problem. So you have to be careful. There's a lot of tedious steps to watch out for. Okay?
All right.
Ugh. This one's a little more complicated. Once again, let's remember, you can work it vertically.
Okay.
Let's remember that we are going to always deal with the negative under the radical before we do anything else. So the first thing is 2 minus. Now, what do you see here? Surely you know that the negative under the radical becomes an I on the outside. Let's go ahead and simplify square root of 12. Square root of 12 is 4 times 3. So the 2 on the outside and 3 stays inside. All of that is over 4. Now, can I cancel the 2 with the 4?
No!
No, we're going to write this as 2 separate fractions, 2 fourths.
Well,
okay, or that. Yeah, we can do that.
Then we can go ahead and factor a 2 out of the
we
top.
We could, but we're eventually,
1
yeah.
minus I square root of 3.
Over 4.
Over 4. We can simplify 2 fourths now because now it's factored. So this is really 1 minus I square root of 3 over 2.
But we want to write it in A plus BI, so it is still 1/2 minus square root of 3 over 2 times I. And you're going to recognize those numbers a little later on when we hit trig. You're gonna love those numbers. Okay, so
Here,
letter D, once again, what's the rule? The rule is deal with the I's first. So the first thing we're going to do is rewrite this with our I's. So this is going to be 1 minus...
Oh, I sure do like this number. 16 is a nice square.
Oh, it is.
So how about if I just take this minus 4i, because I know the square root of -16 is 4i.
Yeah, I like that. 5, hey, same thing here, plus the square root of 36 is 6, and the square root of that -1 that's part of -36 is I. Now we're ready to plain old FOIL, and this is old material now.
Yeah.
So here we go.
All right, we've got first is 5.
Outer is 6i plus 6i. Inner is minus 20i. And last is minus 24i squared. Again, don't ever shortcut that step.
You'll get lost.
You'll make a mistake. So let's just take the time to write the extra step. All right, so we have 5. And then a 6 minus 20. Those are similar terms, minus 14i. And then now we know this is plus 24 and combine similar terms.
29 minus 14i.
Boom. There we go.
All right.
And now...
All right. Here's another ET problem. Go to section 4.5 and do numbers 46 and 49. Pause the video and come back to us in a few minutes. All right. So...
Now, every negative real number has two roots in the complex number system. I's, or notice the misspelling, i's, but notice we have two i's. Every time you have a complex solution, you don't have one, you have two. So that's a really important thing. I's come in pairs. All right, so finding all solutions, if you look at this, wouldn't you, first of all, you don't have a common factor, but don't you see we could just say A is 3, B is -4, and C is 12, and we could just do quadratic formula. So we're going to come over here, and we're going to do quadratic formula. So x equals the negative of parentheses -4 plus or minus the square root of parentheses -4 squared minus 4 times 3 times 12 all over 2 times 3. Now we have a ton of algebra, or aloha, a lot of horrible algebra. 4 plus minus square root of, this is 16, minus 144, all over 6, equals 4 plus minus square root of, that is -128, over 6. Notice, do you see why i's come in pairs? I's happen when we have a negative under an even index. And where does that come from? That comes from the plus minus of your quadratic formula. That is why they always come in pairs. You will never just have one I as a solution. Okay? Next, we get 4 plus minus, well, let's think about 128. So we're going to write that as 64 times 2. Okay.
And 64 is 8.
Yeah, so we'll do that in the next step.
Is 8.
It's over 6. So we have now 4 plus 8 plus minus 8i times the square root of 2 all over 6. Now some of you would want to cancel right here, but we want to be more specific. Let's factor the 2 out of the numerator.
So we've got 2. Why can't we do 4? Well,
2. Want to cancel?
2.
Yeah, do 2.
All right, 2 times 2 plus or minus
4.
4i square root of 2 over 6. Well, 2 and 6 cancel. They simplify to 1/3. So that's
2 plus or minus 4i square root of 2 over 3. And we want to write this in a plus bi form. So we have a couple of changes. So it's 2/3 plus or minus. Now, 4 square roots of 2 over 3 with the I tagging along after. There you go.
And there's two i's here. There's the positive version, so 2/3 plus this, and 2/3 minus that.
Yep, and there's your two solutions. And one last example. The problem we have with this example is if you did it the old way, you would be tempted, let's write that out to the side, you would be tempted to write that, take the square root and say that x is equal to, the cube root, It's cube root of x cubed equals the cube root of 64, take the cube root of both sides, and you would be tempted to say, oh, that gives us that x equals 4. Well, x equals 4 is the only real solution to this problem. But one of the things that we learned prior to Christmas is that because of that x cubed, that means there's 3 solutions. There have to be 2 more solutions hiding in this problem. Well, let's write this as an equation setting it equal to 0. So let's rethink about this problem. Let's write this as x cubed minus 64 equals 0. Do you recognize that as a difference of cubes? And we had a factoring pattern for that, x minus 4 times. Square the first term, change the sign, square the second term, equals 0. Now, remember that if these two factors multiply to 0, one of them is 0, so we already know that the first one is 0 when x equals 4. How do we find the second one equal to 0? Guess what? Quadratic formula. So here we go. A is 1, B is 4, and C is 16. So here we go. X equals -4 plus minus the square root of 4 squared minus 4 times 1 times 16. All of it over 2 times 1.
Sorry, I squared 4 in my head.
I know. So that gives us -4 plus minus square root of 16 minus 64. Over 2, which is -4 plus minus square root of -48. Hey, do you remember the thing called all over 2? Do you remember the discriminant? What's the discriminant?
The discriminant is square root of b squared minus 4ac, which would happen to be a negative number here.
And remember, way back when, we also learned when b squared minus 4ac was negative, there were no real solutions. Why? Because we're going to have imaginary. We have to imagine them. So now let's deal with what we have here. Negative 4 plus minus square. Okay, now, yeah, I like she did with the I. Let's do square root of. What is the biggest perfect square of 48?
4.
No, there's a bigger number. Yes, does 4 go into it? Yes. 4 goes into it 12 times, but 12 would also have a perfect square in it. It's much easier if we find the biggest perfect square, which happens to be
16?
Yes. So 16 times 3 all over 2. If you go for the biggest perfect square to begin with, then you don't have to simplify as much. So we have negative 4 plus minus 4i square root of 3 all over 2. And now we could just do negative 4 over 2 plus minus 4i
over
2 times the I. And now simplify what you can.
Negative 2 plus or minus square root of 3 over
2 square root of 3.
2 square root of 3. There we go. Oops. 2 square root of 3i.
There you go. We're done.
Yay.
And that, my children, is the lesson for today.
So here's your last problem. So go to section 4.5 and do number 60.
And don't forget, there's one more slide.
Okay, so to confirm that you have indeed watched the video, email your teacher by 8 a.m. the day you have class. If you don't email us by 8 a.m., it will be considered late.
Not done.
Or not done.
Not done.
Yeah. You won't get your points for that.
We will not be happy with you. The reason is, guys, we like to look at your questions, look at what you're thinking about, and think about how to respond to that. And if we see your email, if we see it 2 minutes before class starts, that doesn't give us time to be very good with our answers. It also might change which problems we do in class, seeing what you had trouble with. So,
all right, so first, email us one new thing that you learned. Be specific. Number 2, email us 2 good questions. Now, if you don't have any questions, let us know, but try really hard to think of one because I doubt that you have absolutely no questions. And number 3, an old skill that was important to recall for this material.
And there were actually quite a few of them.
Mm-hmm. Yeah. Don't forget to bring your entrance ticket, your ET problems to class, and your completed notes. All right, they need to be completed. All right, we'll see you next class.
Yep, love ya.
Bye.